Mixed reality is used in numerous situated applications, allowing to put virtual content close to or on real-world objects. However, we only know little about which properties of the environment influence how this virtual content is placed and perceived. Based on a preliminary user study with 8 participants and a small-scale literature research, we created a two-dimensional design space which can be used to inform and assist in future layout design. As the first dimension, spatial coupling describes the geometric alignment of virtual content to physical objects in the situated environment, and we define 5 of those alignment types. Positional alignment refers to the spatial distance to or the spatial gap between the referent object. Shape alignment describes how close the virtual content follows the targeted surface general shape, contour, or texture. Rotational alignment characterizes the rotational distance or difference to be leveled to the surface of referent object. Scale alignment refers to the similarity of the size or extent to the referent object. And lastly, motion alignment considers if and how those properties also alter according to changes in position, rotation, or scale in space of the real-world object. As the second dimension, we define semantic coupling, which considers the presence of informational meaning between virtual objects and the object in the immediate environment. For example, objects might share related concepts, or the environment is the data source of virtual visualizations. In the current state, we define semantic coupling as binary, with it being either present or not present. Together, the two dimensions describe the perceived unity through a spectrum, describing the degree of forming a complete and harmonious whole from virtual content and physical objects in the content's environment, similar to being perceived as belonging to each other. To demonstrate the applicability of our spectrum, we situate existing related work into it. First, we look at non-semantic coupled examples. Pictures grouped in AR and only placed in relation to the immediate surrounding can be called situated. As virtual content gets deformed based on the presence of real-world objects or persons, we move toward a higher spatial coupling. Virtual content that fully aligns on the surface of the surroundings, which, for example, enables moving a mouse cursor across the surface, can be seen as integrated. Second, we look at semantic coupled examples. A low spatial coupling allows presenting information to groceries in a supermarket and can be called semantic situated. With available surfaces starting to get used for the alignment of virtual content, while the surrounding objects control the content, we move towards a higher spatial coupling. Finally, supporting the architectural and furniture changes that align and respect the environment, like for an industrial production plant, can be seen as semantic integrated. With our contribution, we wish to inspire the discussion of universal design guidelines for future workspaces. As this project only represents a first step towards the understanding of the unity between real-world and virtual objects, we still see several follow-up steps. Those include examining the presence of real-world content, like sheet of paper on a table, discussing another type of dimension for semantics, like tertiary or continuous, or identifying the concrete factors each change in dimension affect the perceived unity. For a more detailed view, please refer to our paper.